Okay, a bracket in the form of a plate is fitted to a column by means of 4 rivets A, B, C, and D in the same vertical line as shown in the figure. Now AB, BC equals to CD, which is all 60 mm here, 60 mm. So this is your rivet A, B, C, and D. So this is 240. Okay, so I think this is 240. 240. Okay, the whole thing is 240. Okay, E is the midpoint of BC. E is the midpoint here. Okay, that means the CG of the midpoint of BC. A load of 100 kilonewton now. So you see this load here, 100 kilonewton, is acting at an angle of 30 degree. Okay, so when you consider the primary shear load on each rivet here, okay, so the line of actions of your primary shear load on rivet A, B, C, and D should be parallel to this force here. So that means somewhere around here for each rivet. Okay, and then for the eccentricity, you have to draw this line over. Okay, the line of action of this force 100 kilonewton. Draw a line like this, extending outwards. And then from the center of gravity, draw a line downwards. So these two lines that you have drawn must touches each other 90 degree to each other. Okay, 90 degree to each other. So you know this angle will be 30 here. Okay, this should be 90, so this will be 60. Okay, so that is what it is given here. So you see your primary shear load, every primary shear load is parallel to this force here. Okay, this P100 kilonewton. Okay, parallel to this. Okay, so that is your PS, 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 and PS. Okay, so your eccentricity is taken here. So this will be your eccentricity. Okay, so from the CG, this line is drawn. And from this force, this line is drawn. So this should be 90 degrees, and this is the eccentricity. And we know that, okay, this length here is how much? This length here is 150. Okay, 150. And you know that this angle is 30, so this angle will be 30. So with 150 and this angle 30, you will be able to find out the eccentricity E here. Okay, the eccentricity. But then now, when you refer to this force multiplied by this length E here, it will give you a turning, counterclockwise turning. Oh, sorry, clockwise turning. It's a clockwise turning. So clockwise turning, so therefore this FA, FB, FC, and FD, when you multiply by the radial length LD, FD with LD, FC with LC, FB with LB, and FA with LA will give you a clockwise turning as well. Okay, so therefore your FA, both your FA and FB is pointing towards the right. Your FC and FD is pointing towards the left. Now, how do we know that these secondary forces here are all horizontal? Because all your radial lengths are vertical. All the radial lengths are vertical. So this secondary shear force and the radial length must be 90 degrees to each other. So that is why these forces here, when you see, is being horizontal. And why these two is acting to the left and why both of these is acting towards the right. Remember, this force times its radial length have to produce a clockwise couple. Okay, have to produce a clockwise turning moment due to this P times E here. So how much is this PS here? So you have to take 100 divided by 4. So each of these direct shear load or primary shear load here should be 25 kilonewton or 25,000 newton. So the direct shear load on each rivet acts in the direction of the 100 kilonewton. So the primary shear load all acting in the direction of this 100 kilonewton. The center of gravity of the rivet group lies at E. So the center of gravity here. Now find that the perpendicular distance from the center of gravity E to the line of action of the load. So you have to know how much is LB, how much is LA, how much is LC, and how much is LD. So your LA should be how much? Should be 90. Your LB should be 30. Your LC should be 30. And your LD should be 90. Okay, then EG. The next thing is you have to find out the EG, that is the eccentricity. So why? Because you need to know what is the turning moment, the total turning moment. That is P times E. So that is why you have to find the eccentricity E. Yeah. Okay. So P times E will give you a 7,500 times 10 to the power of 3 Newton millimeter. Okay. Now this turning moment is resisted by 4 rivets as shown. That is FA, FB, FC, and FD. B the secondary shear load on the rivets. So we have found out the radial lengths LA to LD. And then based on this formula here, we use the same formula. Okay, I know what that's that formula just now. Okay, so based on this formula, you have this to be the subject, to be the subject. Now refer back to this for the example just now. Yeah, afterward, refer back to this for the previous example. Okay, so changing FA to be the subject. Okay, when FA is the subject, then since you know the P times E and you know all the radial lengths, so you will be able to find out FA, then FB, then FC, and FD. So once you have found out all the secondary shear load, then you need to find out the angle. Now this is much easier to find out these angles here. So you just have to look at the geometry of the figure. Then find out your RA, RB, RC, and RD. Okay, so these are the angles 30, 30, 30. Now when you refer to this parallelogram, and this parallelogram here. Okay, so what is the theta? So you have to find out the theta. Then once you have known the all the secondary, the resultant shear load, all the resultant shear load from RA to RD, so you pick up the maximum. You pick up the maximum resultant. Then diameter, the subject. Now the shear stress given is ultimate, if I'm not mistaken. That is why you divide by factor of safety. Then the factor of safety is given as 1.5 for this question. So from that, you can find out the diameter of the rivet to be 21.9 mm. So actually, you can assume it as 22 millimeter. Okay, always larger but not smaller than this value. Okay, that's for this example. Thank you very much.
Attendance.